Hi guys, welcome to another episode of MrLopezClasses.com. We are going to continue in our chapter 6 and this is the episode number 3. In this episode we are going to analyze where is the leak. Where is the leak that affect the corrosion in my boat in that specific area? Where is the equipment with the leak of current? And for that purpose, we are going to use 3 different procedures. We can check where is the leak checking the voltage method, or checking the amps methods, or checking the resistance method. In my opinion, the voltage method and the amps, the first, this one, the voltage and the amps, they are, in my opinion, the best. The resistance, in my opinion, is not accurate because in a boat you have too much returns, and it's difficult measure exactly the resistance. This is, in my opinion, the less accurate. But I mentioned, but the voltage and the amps always work. Okay, my friend, it's clear for us that we need to keep the boat clean, keep the boat dry, keep the boat properly bonded, all the metallic parts properly bonded. Doesn't matter if the metallic part is over the water line or below the water. It's metallic, it's inside of the boat, it shall be connected to the bonding system. Everything. And it's clear that we need to select appropriate alloys, marine alloys, non-ferrous alloys, ferrous alloys. Yep. All of those concepts are clear. And now we are going to analyze where is the leak. Because everything is clean in my boat. Everything is dry. The materials are properly selected. I have the sacrificial anodes installed. And I have a couple of elements in the port side of my boat corroded. You need to analyze in that area what is the equipment with a leak of current, and that leak of current accelerates the corrosion in that specific area. Probably it's a cable, positive cable, touching the block of an engine or a generator or a water maker. Or is the case of an appliance improperly bonded, or is the motor of an appliance with a leak with a small short to ground, especially when it's running, or is the switch, is the interrupter. We are going to check the method, the 3 methods. This is the first one in order to check the voltage. You see that picture? Let me I analyze the picture carefully. This is the battery, and we are going to disconnect the main positive of the battery from the positive terminal of the battery. And I am going to insert in series my multimeter. For both methods, the multimeter should be inserted in series. Look at this. In this particular case, if I disconnect the positive cable and I try to check volts, this is the DC panel, for example. I disconnect the positive in between the positive terminal of the battery and the cable. I disconnect the cable and I insert my voltmeter in series over there, volts DC. How much should be the reading of the voltage? Should be 0 because it's positive with positive. No, I have 12. It's because in the boat you have some equipment touching the ground. For that reason you read 12. In that point. Simple. Okay. In between this and this, I am going to install a breaker. And I interrupt with the breaker in order to avoid separate that big cable. I install a breaker right now in the video clip. I am going to show that procedure. Alright? It's not complicated. This is the volt method. Once again, I'm going to separate the positive terminal of the battery or I am going to install an interrupter over there and I open. When the interrupter is off, when the breaker is off, it's because the terminals are on. Look, if it's off, it's because the terminals, the contacts are open. If it's on, it's because the terminals are closed. Don't forget that. It's off, the terminals are open. Okay? Alright. Once again, this is the switch selector, the positive, the main breaker of the panel. Some small boat with a DC panel, they don't have main breaker. The positive enter in the common of the breakers, that one. And in the output of each breaker, you have the connection to each equipment, to each motor, to each appliance. Each equipment have your own switch. The switch, for example, this is a vacuum. Oh, the equipment is connected to the power, but this is the switch to activate the motor, the appliance. Alright? What is the idea? The main breaker is on, contacts close. And all the small breakers are on, contact close. However, the equipment is off, because the breaker at the input of the equipment is off. And I am going to disconnect the positive from the terminal of the battery, and I am going to insert my multimeter over there. In normal conditions, the reading should be 0. 0. 0. Because it's the positive. You have the positive cable, you interrupt the positive, and you try to read voltage in between this and this. It's 0. It's 0. Oh, I have 12. It's because in the other side, some equipment is touching the ground. You have a leak. For that reason, you have 12 volts over there. Simple. How can I know where is the equipment? With the next method, with the amps, you can verify that. With this method, you are 100% sure that you have a leak. Probably if you disconnect in the output of the breakers, here, in the output of the breakers, the equipment immediately, oh, disconnect the second one. Oh, 0. Okay, that's the equipment. Yeah, this is the method. With the amps method, we are going to do the same. We disconnect the positive from the positive of the battery, and we connect in series the ammeter in amps. Remember, switch the terminals of the ammeter. We are going to do right now in the video clip. And exactly the same. All the breakers on, and off at the input of each equipment. Off. And we are going to check if the reading in amps in the ammeter is less than 1 milliamp. How much is 1 milliamp? 0.1 milliamp is 0.001. If I have less than 1 milliamp, the situation is considered not critical. If it's more than 0.01, it's critical. Yeah, I have a good example, and we are going to check on the board right now that example. Alright? This is not complicated. We are going to follow the procedure in this way. Hey guys, I have a board that I prepared in order to understand the procedure to identify where are the leaks. This is the typical DC panel. This is the DC wiring in a boat. I have the DC panel with an ammeter, voltmeter. I have 5 elements connected right now. I have the freshwater pump, the blower, bilge pump, navigation lights, cabin lights, and the horn. All of those elements are working. The pump, the lights, the bilge pump, everything is running in good condition. I am going to use both methods, the method of the voltage and the method of the amps. This is the connection. The positive of the battery is interrupted here, the positive enter here, and I interrupt with this breaker. And the positive continue. The positive continue here in the fuse, enter in the shunt for the ammeter, that's the shunt for the ammeter, and the positive enter in the positive bus bar of the panel. The negative bus bar is connected with the negative and is connected with the negative of the battery. The rest of the elements, this is the ignition bus bar, and this is the wiring for this particular boat. Now, I am going to try to connect my voltmeter in series according with the diagram. In the diagram, if you see, the negative is connected with the positive of the battery. This is the positive of the battery. I am going to select volts DC. Volts DC. The positive of the battery is here. And this is the other positive. I interrupt over there. In the other positive, I connect here. Normally, the reading, because I interrupt the positive, the reading between those points is 0. If I have the voltage of the battery, 11 volts or 12 volts, the voltage of the battery is because after that, some equipment have a leak. Some equipment have a return to ground. Let me check. Oh, I have 11 volts. I have 11 volts. What is the meaning of that? Is because one of the equipments have a leak. Okay guys, everything is running. Everything is running. Right now I am going to disconnect that breaker. I am going to interrupt the positive. And now I am going to check the voltage over there. And the voltage is 12 volts. It's supposed that it's interrupted. I separate the positive here. If I connect, everything is running. Okay, I separate the positive and I connect my voltmeter in series on the separation. And I have 11.6, the voltage of the battery. What is the meaning of that? That I have a leak in one of those equipments. Where is the leak? One method is I disconnect in the output of each breaker the equipment and I verify in what moment the voltage becomes 0. This is a perfect indication. Alright? And I am going to verify with the method of amps. Let me explain what happened with the method of amps. With the method of amps, once again, I am going to switch the terminal in my multimeter into amps, and right now I can select amps and I am ready. Once again, the positive of the battery with the negative terminal and the positive of the multimeter with the other positive that enter in the system. If the reading in amps is more than 0.001, is because I have a leak. With the volt method, I verify that I have a leak. I am going to verify again with the amp method. Alright? 0.03, 0.029, 0.03. This is more than 0.001. This is an indication. This is an indication that I have a leak. Now I am going to disconnect in the other side the breaker with the problem, and immediately the voltage will be 0. Now I am going to disconnect the terminal of the pump, and I am going to verify what happened. Now the flow of amps is zero. It's because this pump is the equipment with the leak. This is a simple technique to identify where is the leak. With the volt method, the amps method, or the ohms. In the ohms method, this is not accurate because you have too much returns. In the both methods is with the negative terminal of the battery with the multimeter in ohms. But I have a lot of experience with that method, and always is erratic because you have a lot of returns. For that reason, I prefer the volt or the amps method. Don't forget that we need, at the end of the day, in all the boats, the negative bus bar in the DC panel, this one. The negative bus bar on the DC panel, that one. And the ground bus bar on the AC panel, both of them shall be connected to the bonding conductor, and the bonding conductor finish into the piece of zinc. This is mandatory. You need to verify that the ground bus bar on the AC and the negative bus bar on the DC be connected together with the bonding conductor. That's the last element in the electrical part that you need to verify. And of course, you need to verify that the sinks on the transom be properly connected with the bonding and properly separated from the transom. Normally, one finger of separation in between the sink and the transom. Of course, the sacrificial anode in an aluminum boat shall be separated properly and isolated with plastic bushings or silicone bushings in order to separate the electrode from the transom in aluminum. Remember, if the boat is in aluminum, the sacrificial anode recommended for salt water is magnesium. Okay? Alright? Later we are going to talk about the different type of sacrificial anodes depending on the material of the hull. This is in a next coming episode. Thank you.